welcome back. In this video I want to talk about some other examples involving the tangent inverse functions. Guys, here I have to evaluate the tan inverse of negative radical 3. So in order to do that, the first thing that I'm going to do is I'm going to look at the restrictions for the tangent inverse function. And here I can clearly see that the range is restricted between negative pi over 2 to positive pi over 2, and it does not touch the endpoint. So let us go ahead and actually draw that. So on a unit circle, it looks something like this. These are open circles because it does not touch the endpoints. This is negative pi over 2. This is positive pi over 2. And then we have to be a little careful. One thing, this is a negative radical 3. Obviously, we know that this is not going to be in the first quadrant because all the values for and all the trig functions are positive. Since it's a negative, so obviously it is going to be in the fourth quadrant, right? This fourth quadrant right here. Okay, so we are only going to focus on the fourth quadrant. Guys, keep in mind, tangent or any of the other functions except for sine or cosine are not directly written out on the unit circle. What is on the unit circle is the values for sine and cosine. But we already know the basic identity that the tangent of any angle is the ratio of the sine over cosine. So let me quickly write that. Tangent is the sine over the cosine. Keeping that in mind, guys, we want a negative radical 3. So I'm going to look at my unit circle, and right away I can see that for this particular value, and that is negative 60. But let me first write the points. I have 1/2 and negative radical 3 over 2. Guys, this is the point that I feel is going to give me a negative radical 3 when I take the ratio of the sine over cosine. But let us not just jump to the conclusion right away. Let us first make sure that by taking the ratio of those two values of sine and cosine, I get a negative radical 3. If I do, then that is my angle, right? So let us try to simplify this. It is going to be negative radical 3 over 2. I got to divide by 1/2. Obviously, this is same as negative radical 3 over 2 times 2 over 1. That's how we simplify these ratios, and 2 crosses out, I get a negative radical 3, and that's exactly what I have right here. So that convinces us. So guys, I'm not just going to just look at it and see that there's a negative radical 3 up here and I'm going to conclude that that is my angle right there, that is my point and that's my angle. No, guys, I'm going to first make sure, I'm going to do the math and make sure that I get that negative radical 3, because sometimes with this tangent inverse or cotangent inverse, they can be tricky. So you got to do your math and check before you start actually writing the final answer. So now we are convinced that this is the right point. And what is the angle? The angle is, guys, negative 60 degrees. So that means the value for the tangent inverse of negative radical 3 is 60 degrees. Or if you want to keep it in radians, then guys, this is, sorry, not 60, negative 60, because it is below the x-axis and it is same as negative pi over 3 radians. Guys, this is how you evaluate the tangent inverse of a value. Okay. I want to do one more example, and then, guys, we are going to go into some other details about the inverse functions, and finally we're doing all this to actually get to this point where we can use these things, use the idea of the inverse trig functions to solve trig equations. So the other example that I want to do is number 5. I want to see how we can evaluate tangent inverse of negative radical 3 over 3. So guys, this is a little trickier than the previous one, but we are going to make it work. Now, in order to do that, again, we have to go back and we have to first look at the restriction for the tangent. I'm not really worried about the domain. All I'm looking for is the range. With that range is the same thing. It's between negative pi or pi over 2. So let us kind of draw that. It's going to be easier for us if we actually have it visually in front of us. No, it does not touch the endpoints. Negative pi over 2 to positive pi over 2. That's the range for this. Now we are again looking for a negative value, and that means it's not going to be in the first quadrant. It is still going to be in the second quadrant. Sorry, not the second, I mean the fourth quadrant, somewhere here, right? This is my x-axis and this is my y-axis. Now, again, it's not directly provided to me, but we know that the tangent is the ratio of the sine over cosine. Guys, before we start doing that, let us, first of all, we should remind ourselves that its tangent of any angle is the ratio of the sine over cosine. And looking at all the values there, guys, again, my eye catches catches that same point, 1/2 and negative radical 3 over 2. because there's a negative radical 3 upstairs. So I'm tempted to use that point, but I already have used that point in my previous example, and I know if I use that point, I take the ratio of the sine over cosine to get the tangent, I just get a negative radical 3. And guys, that worked well for this because here I wanted to evaluate the tangent inverse of negative radical 3, so it matched, so we were fine. But here I'm not evaluating tangent inverse of only negative radical 3, it is divided by 3 as well. So that means that point is not going to be the right point for me to use in order to find the tan inverse of this ratio. Then guys, if I cannot use that point, what other option do I have? Guys, the one way is to kind of try all the points, but then if I look at the points on the unit circle, I can see that I have 3 options. I only have 3 options. What are those? Those are negative 30 degrees, negative 45, and negative 60. Negative 60 does not work. We already saw that from previous example. Guys, negative 45, if I look at the negative 45, I mean, if you have to have a unit circle in front of you to see that. What I see is I don't see any radical 3's going on, right? It's only radical 2 over 2 and negative radical 2 over 2. So there's no way that is going to give me a radical 3. Then the only point left is negative 30 degrees. It has a radical 3 term. So I should give that a try and see if we can, once we simplify everything, we may get what we need here, which is negative radical 3 over 3. So let me try this point right here, which has coordinates positive radical 3 over 2 as my x coordinate and negative 1 over 2 as my y coordinate. Obviously this is my cosine and this is my sine. So let us try that. Sine is negative 1/2 divided by cosine is radical 3 over 2. When we simplify this, it looks like this. Negative 1/2 times 2 over radical 3. It just flips. This crosses out. What I get is negative 1 over radical 3. Now we know that we don't usually leave these ratios with radicals in the denominator. Whenever we have a radical in the denominator, we have to rationalize the denominator. How do you rationalize? You multiply upstairs and downstairs by whatever is in the denominator. In this case, you multiply by radical 3. I multiply upstairs by radical 3, downstairs by radical 3. When I simplify, I get negative radical 3 over 3. And that's exactly what I have right here. So our guess was correct that it is going to be this angle right here, and which is negative 30 degrees. Again, it's below x-axis. So our final answer for this number 5 is going to be negative 30 degrees. So final answer is negative 30 degrees, or you can think of that as negative pi over 6 radians. So guys, please be careful when you are working with the tangent inverse, or for that matter, cotangent inverse, any of those functions which are like little more advanced than the basic sine and cosine functions, but it can still be done using the unit circle. And for all of these types, guys, one has to heavily rely on the range values. Either you have to try to remember them or you have to have them in front of you. Okay, so guys, I will see you in the next video with some other concepts regarding the sine inverses and the cosine inverse and the trig inverse trig functions in general before we start working on the trig equations. Till then, take care. I will see you next time.